And let's get to it. This is paper 6.2 from summer 21, and we're looking here at question 7, which is all about electricity. Okay, should be getting used to this. It's quite a common setup. This is the power supply attached to a resistance wire, and we're going to change that value of L and see what happens. So first thing we're going to do is fill up the table. All right. Now this is quite a tricky one. We've first been asked to measure the current. You'll notice here this is where we some teachers may disagree on how you're meant to do this one. There's a very much a CIE way of doing this. If you'll notice, it's one of the very few occasions where we have our pointer existing halfway between two divisions. Each of these divisions is 0.5, 0.4, 3, 2, 1. So each division is 0.1. So that means that my value is going to be somewhere between 0.2 and 0.3. Now, when I was growing up, we were told not to do this, but it's very much the thing now. You can assume that this pointer is right in the middle. Okay, and so therefore we can read the value as halfway between 0.2 and halfway and 0.3, therefore 0.25. Okay, like I say, some teachers in particular may not feel comfortable with that because we're often taught that your precision is limited by the precision of the equipment you're using. Don't worry about that. You can assume it's right in the middle, and you can kind of take your cue from the value of the current beneath, which is 0.25 as well. So you're allowed to give that level of precision. All right. We then have our voltage, a voltmeter, and we are reading quite a tough scale to read there. We're going 0.1, 0.2, 0.3, 10 divisions between the two. So each one of those divisions is 0.01, which is why my value here is 0.21 volts. Okay. We're then asked to calculate resistance. Again, it's a core paper, so you don't need to remember the equation. It's quite nice to have that equation given to you. And we'll do the calculation, set out our working, and then enter the value 0.4. Now you'll notice at the top there, we're missing a unit, and that's the units of our resistance in ohms. Okay, but the thing that I'd like to highlight to you at this point is that in the other column here, just in case you've forgotten what the units of resistance is, well, we've got R divided by L. And so the units of R divided by L are going to be units of R, ohms, divided by centimeters, units of length. And so therefore, if you've really forgotten what the units are, that unit there is exactly the same. A nice little freebie there, I think. Okay, so we'll do that calculation. We're asked to insert that missing unit, so tick that off. And we're asked to calculate R over L. Okay. Now, the teacher states that the resistance of the wire is directly proportional to its length. Okay, and you're basically being asked, well, does your value support that? If you notice here, okay, for example, we've doubled our length each time, 10 to 20, 20 to 40. Okay, we've gone from a 0.8 to a 1.6. That's approximately double. We've gone from a 1.6 to a 3.4. Again, approximately double. Now, I think if I was really taking this question very seriously, what I might do is then go off and do a bit of percentage differences here, calculate the percentage difference between what the values should be and what they actually are, and you'll find that the percentage difference is less than 10%, and so therefore our values in the table do support the answer. Okay, but because this is a one mark question, if we have a look at the answer scheme here, we're really just saying a statement here is enough. Double the length doubles the resistance. Okay. Suggest how the student can extend the investigation to have more confidence. I'm laughing a little bit, okay, because this is the same question we've seen before. It's just put in a different way. This question is saying to have more confidence, i.e. to make your results more reliable. Okay, how can we make the data more reliable? Well, again, what do? We do the experiment again. All right. They're really trying to hammer home the point here that even though we're doing an exam about experiments, okay, even though we're sort of talking about technique, really one of the key points there is to repeat data taking. We never do an experiment 3 times. We do it multiple times, 5 or 6, 10 even, so that we can get good data that we can then believe. All right, last one. Suggest why the switch is open while we change the length of the wire. Okay, we look there, the wire gets hot, and that's to prevent overheating. As we know, when we disconnect the circuit, the current will stop flowing, and therefore there will be no energy wasted in the circuit. You could also say to stop energy being wasted. You could also say to prevent the battery from running down, etc. I've avoided my usual temptation of writing to stop getting an electric shock, but I was very tempted, I'll be honest with you. there we go, folks. That's a nice question, I think. Okay. Please do let me know if you've got any questions, be it ones from past papers you'd like answered, or ones about this one, or ones about electricity in general. Very happy to help. Thanks for watching.